What is a heat exchanger? For cooling system design. Imagine a device that can transfer heat from one fluid to another without mixing them together. That's what a heat exchanger does. It plays a key role in controlling temperatures in many systems. In cooling systems, heat exchangers remove excess heat from equipment or processes. They transfer this heat to a cooler fluid, like air or water, to keep everything running smoothly. For example, in cars, the radiator is a heat exchanger that cools the hot engine coolant by passing it through metal tubes. Air flows over these tubes, taking away the heat. This prevents the engine from overheating and keeps your car running efficiently. Heat exchangers come in different shapes and sizes. The most common type is the shell and tube design. It has a series of tubes inside a shell. Hot fluid flows through the tubes, while cold fluid flows around them inside the shell. This setup is great for high-temperature and high-pressure applications. Plate heat exchangers are another type, made of stacked metal plates with small gaps. They are compact and work well for smaller or more precise cooling needs. Flow arrangement is important too. In counterflow designs, fluids flow in opposite directions. This setup transfers the most heat because the temperature difference stays high along the entire length. Parallel flow, where both fluids move in the same direction, is less efficient but simpler to set up. Cross-flow configurations have fluids moving perpendicular to each other, often used in air conditioning systems. The heat transfer process involves conduction and convection. Heat moves through the metal walls by conduction, then is carried away by convection on both sides. Sometimes, phase changes like evaporation or condensation happen to boost heat transfer. For example, in a refrigeration cycle, refrigerant evaporates to absorb heat and condenses to releases it. Choosing the right heat exchanger depends on several factors. You need to consider the temperature difference between fluids, flow rates, and the properties of the fluids involved. Space and weight constraints are also important, especially in vehicles or portable equipment. Maintenance needs and durability are key for long-term operation. Cost and efficiency goals influence the final choice. In practical use, heat exchangers are everywhere. Automotive radiators and oil coolers keep engines at safe temperatures. Air conditioning systems transfer heat from indoor air to refrigerants, making spaces cooler. Industrial plants use large heat exchangers to remove heat from machinery or chemical reactions, ensuring safe and efficient operation. Understanding how heat exchangers work and how to design them properly is vital for mechanical engineers. A well-designed heat exchanger ensures effective heat removal, keeps systems safe, saves energy, and extends equipment life. Whether in cars, factories, or buildings, they are essential tools for managing heat efficiently.